Okay, we're going to look at 10.4, graphing quadratic equations, and you're going to need your TI 83 or 84 calculator out because we're going to be using our calculator a lot for this. So there's examples of quadratics all around us, and just to remind you, a quadratic is of the form ax squared plus bx plus c equals 0. So we have a variable raised to the second power. An example you could think of, one would be a bridge. So this is the ground, and this point right here would tell you the height, the highest point of the bridge. Another example, if you did the other way around, this is the ground, and this is an example of a pool, and this point right here would tell us the largest depth of that pool. We can tell if a quadratic opens up or down, like the example of the bridge or the pool, based on a, the number in, or the sign of the number in front of x squared. So if that number is positive, then the graph is going to open up. And if that a value is negative, it's going to open upside down. So you can tell right away just by looking at the equation if you have a U shape or an upside down U shape. So let's graph y equals x squared, the most basic quadratic, and I'm actually going to graph this on here and not on the calculator right away. We'll do this one by creating a table. So I'm just going to pick some values, -1, 0, 1. So if x is -1, -1 squared is 1. If x is 0, 0 squared is 0. If x is 1, 1 squared is 1. And let's do one more. If x is 2, 2 squared is 4. So I'm going to go ahead and plot these points. -1, 1, 0, 0, 1, 1, and 2, 4. And a quadratic is always a mirror image on both sides. So it kind of goes up here. And remember, this is supposed to be a U shape. And I can see from here that this one would also go up. Whoops. Let me fix that. This would also go up in that same. Okay, so it should be a mirror image, just a little sloppy. And I just want to point out a couple of things. This point right here, in this case it's the lowest point, since our graph is down, is called the vertex. And then we have what's called an axis of symmetry. That's the line that goes directly down the middle of the parabola through the vertex, and it divides the parabola in half. So if I fold it along this axis, the two sides of the graph would meet. This is called the axis of symmetry. And this is a vertical line. And so remember, vertical line has the equation x equals whatever this number happens to be, x value that it's going through. And then I just want to point out the domain and the range. So on this graph, the domain, what x values are used? Well, there's no breaks in this graph. Every x value is used, so it's all real numbers, or -infinity to infinity. And for the range, if we follow the y-axis from -infinity to infinity, you notice your first y value starts right at 0 and goes up. So it's y is greater than or equal to 0, or you could write that in interval notation. So how do you find the vertex? I'm going to show you two different ways to find the vertex. One is algebraically, and then I'll show you on your calculator. So algebraically, to find the x value of your vertex, you use the formula -b over 2a. So remember, it's the ax squared plus bx plus c equals 0, as long as it's set equal to 0. A is the number in front of x squared, b is the number in front of x. So you just plug in -b over 2a. And that vertex is a point. So your x value is the -b over 2a, and the y value is whatever you get when you plug this x value into your equation. I've also put down the directions on how to find this using your calculator, so they're here in front of you, and you can come back and use these. Okay, so let's practice. Find the vertex of y equals 3x squared plus 2x minus 4. And I'm going to do this algebraically and with the calculator to show you both ways. So algebraically, whoops, hold on. We're going to say x equals negative b, so our b value is 2, over 2 times a, and a is 3. I'm just going to simplify. This is negative 2 over 6, which reduces to negative 1/3. So that's the x value. To find the y value, you need to plug in negative 1/3 for x and solve for y. So this would be 3 times 1/9 minus 2/3 minus 4. This equals 3 times 1/9 is 3 over 9, or 1/3. So you have 1/3 minus 2/3 minus 4. I'm going to rewrite 4 as 12 over 3. I just got a common denominator. And I get 1 minus 2 is negative 1. Negative 1 minus 12 is negative 13/3. And just to help me visually see where this is, I'll write this as a mixed number. That would be negative 4 and 1/3. So your vertex is the point negative 1/3, negative 4, and 1/3. You could also, for this y equals right up here at this stage, you could just put this into your calculator just like you see right here, and you should get negative 4 1/3. In fact, I'll write it down. I'll show you how you would do this. And then use the math button. Okay, so let me show you. Go to the calculator, and I'm going to type in 3, whoops, hold on one second. 3 times, oops, times negative 1/3 squared plus 2 times negative 1/3 minus 4. Hit enter, and your calculator is going to get your decimal answer. If you want, you can either know that 0.333 means 1/3, or you can hit the math button and see where it says 1 fraction. You hit enter, and it'll convert. First, you have to hit enter. You'll convert your decimal to an improper fraction of negative 13/3, and then you do have to convert that to a mixed number, which is the negative 4 1/3. Okay, now I'm going to show you how to do this using the calculator. So first thing you need to do is graph this quadratic. So hit y equals, and we're going to type in the 3x squared plus 2x minus 4, and then hit graph. Okay, so there's your quadratic, and we are looking for the vertex, which is this very bottom point right here where the graph switches from decreasing to increasing right at that point right there. So to find that, remember these directions are on that PowerPoint. You hit second calc, and when you're finding this vertex, it's the lowest point. It's actually your minimum. So you're going to hit 3 for minimum. And it's going to ask you left bound. So you need to go just to the left, anywhere to the left of your vertex, it doesn't matter. Hit enter. And now it's going to ask you for the right bound. So go somewhere to the right of your vertex. Don't cross this y-axis. Just go somewhere to the right and hit enter. And then it's going to ask you, do you want me to guess? Question mark, and hit enter. And then you get your minimum or your vertex, which is negative 0.333, negative 4.3. And that's just in decimal form. This is negative 1/3 and negative 4 1/3. Okay. So those are two different ways to find the vertex. Now the axis of symmetry, remember that's the line that goes directly down the middle of your graph. And it's really easy to find. It's a vertical line. It's always of the form x equals, and it's whatever that x value of your vertex is. So in our case, our vertex, remember, was negative 1/3, negative 4 1/3. That was the lowest point. Let's see if I can. Okay, so that vertex was right here. That was our lowest point, negative 1/3, negative 4 1/3. And the axis of symmetry, so here was our parabola, right? That axis of symmetry goes directly down the middle, and it's the x value of your vertex, so it's x equals negative 1/3 is that value of that axis of symmetry. It's a vertical line. Okay, to find the y-intercept, this is actually pretty easy. So remember the y-intercept, let me show you on this graph, would be where does your graph hit on the y-axis. So in this case, our y-intercept would be right here. It's actually very close to the vertex and on this graph. And that value, the y-intercept, x is 0 at that value because you haven't moved to the right or left any. So to find the y-intercept, oops, let me go back one. To find the y-intercept, you just plug in 0 for x and solve for y. Okay, and that'll find your y-intercept. So let's practice. We're going to find the y-intercept for the same graph that we just had. So all I need to do is plug in 0 for x, and you'll see when you're plugging in 0 for x, basically what happens is any term with an x in it gets canceled out. So a lot of times what I do is actually just ignore all those terms with x, and your answer is that constant, that number all by itself. So in this case, y is negative 4. So remember, this is a point. X is 0, y is negative 4. That's your y-intercept. To find the x-intercept, you're actually doing the opposite. So again, let's look at our graph. The x-intercept, we'd want to know when does our graph hit the x-axis. So we have 2 points here, one to the left and one to the right. I need to know what those two values are. So in this case, it's when y is 0. So let's go back. Find the x-intercept. Plug in 0 for y and solve for x. You can use the graphing tool to do this, but I actually usually do this a different way, and I'll show you with this example right here. We're going to find the the x-intercepts for that equation we just graphed. So we have 3x squared plus 2x minus 4 equals 0. Okay, and we're trying to find what these x values are. I could try and factor this, or I could use the quadratic formula, and we actually have that programmed into our calculator. So the easiest way to find these x-intercepts is to use the quadratic formula. So I'm going to go back to my calculator, and I'm going to hit program, execute quadratic formula, hit enter. We're going to type 3 in for A, 2 in for B, and then negative 4 for C, and hit enter. And you get your two x-intercepts. First, I'm going to round, so 0.87 and negative 1.54. So let's go back here. Remember, these are 2 points, so the x-intercepts, x is 0.870, and we also have negative 1.540. So those are the two values where it hits the x-axis. Okay, for the domain and range, for the domain, unless you're dealing with a word problem where maybe you're only looking at positive answers, your domain could change. But in general, for any quadratic that doesn't have any restrictions, which we're mostly going to be dealing with in this class, so you have the u or the upside down u, your domain is all real numbers. You can plug in any value for x and you'll get a y value. So there's no restrictions, unless I say I'm in a business and I don't want any negative units of something. For the range, the way to think of it is if you have the U shape, remember this is your vertex right here, some y value there, right? So y, your domain is going to be y is greater than or equal to whatever that y value is. Okay. If you have the upside down u, and here's your y value, let's call it b again, then instead of being greater than or equal to b, it's going to be less than or equal to b. So it just depends on what direction your quadratic is. So let's find the domain and range of the same graph that we graphed a minute ago. So the domain, we've already said there's no restrictions here. It's negative infinity to infinity. And you can see from the graph, right? Let me graph it real quick. Over here, you can see that there's no gaps in this graph for x values. Any x value can be used. Now for your y value, starting at negative infinity and moving up, your y values start right at this point right here where your vertex is. And remember, we said that y value of our vertex was negative 4 1/3. So we would say our range is y is greater than or equal to negative 4 1/3. So negative 4 1/3 to infinity if I wrote it in interval notation. Okay, so let's do all of this for one graph. Y equals 2x squared plus 4x minus 5. So we want to find the vertex. So I'm going to do this on the calculator. You could do it algebraically if you wanted to, but I'm going to go ahead and graph it. So hit y equals, I'm going to clear this out, and I'm going to graph 2x squared plus 4x minus 5 and hit graph. Okay, so this is very similar to the last graph we did, and now we're going to find that vertex. In this case, is our lowest point. So I'm going to hit second calc and number 3 for minimum. Left bound, I'm going to go somewhere to the left of the graph, hit, or the vertex, hit enter. I'm going to go somewhere to the right of the vertex and hit enter. And it says guess, so I'm going to hit enter. And I get negative 0.99999, which is basically negative 1, negative 7. So I'm going to go ahead and write all this down. So my vertex is negative 1, negative 7. Axis of symmetry, remember that's x equals, and then the x value of your vertex, negative 1. Okay, x-intercepts means I'm going to plug in 0 for y, and I'm going to solve for x, and so that, remember, that means I'm going to use the quadratic formula. So 2x squared plus 4x minus 5. So let's go to our calculator, hit program, execute, enter. I'm going to plug in 2 for A, 4 for B, and negative 5 for C. And you get 0.87 and negative 2.87. Okay, so I'm going to write these as 2 points. So I have 0.870 is the first, and negative 2.870 is the second intercept. For the y-intercept, remember that means you plug in 0 for x, which means these two x terms go away, and I'm just left with the y is negative 5. So this is the point 0, negative 5. So I'm going to do a rough sketch of this quadratic. Make sure you label whatever you can. So let's start with the y-intercept of 0, negative 5. Okay, so that's negative 5. Vertex negative 1, negative 7, right here. So that's the lowest point of the graph. And then we have the x-intercepts of negative 2.87, so you're just going to approximate, and 0.87. Okay, and then I'm going to try and draw a U through these points. So here's kind of a rough sketch of my quadratic. The domain here is all real numbers. And then the range, your y values start at this y value of your vertex, which is negative 7, and move up. So its y is greater than or equal to negative 7. Okay, we're going to do the same thing with with example 2. It says the height and feet of a rock thrown upward at an initial speed of 64 feet per second from a cliff 50 feet above the ocean is given by this function, where t is the time in seconds. So we're going to find all the things. Now I just want to point out that when we're finding vertex, if we have the U shape and we're finding the vertex, that's our lowest point in the graph. Like if it was a pool, that's the lowest depth of the pool. This is called our minimum. So if you're asked for the minimum, you're looking for the y value of your vertex. What is that minimum depth, let's say? If you have the upside down U, think of the bridge, then this vertex, this y value of our vertex, is our maximum point, the maximum height of our bridge. So if you ask for min or max, you're asking or being asked to find the y value of your vertex. Okay? So let's find the vertex for negative 16t squared plus 64t plus 50. Okay, so I'm going to use a calculator. And notice this is a negative 16, which tells me I'm going to have the upside down U shaped here. So let's get this clear. So we're going to hit y equals, whoops. And we're going to plug in negative 16 x squared plus 64. Now notice instead of a t, I'm just using an x, so you still use the variable x plus 50. Now hit graph, and you notice you don't see the whole graph, and that's because the numbers are much larger than this window of negative 10, 10. So what you need to use to help you is I know that this is an upside down U, which means I know I'm missing the top of my graph. So you do have to know whether you have a U shape or an upside down U. So I need to see more of these Y max values so I can see the top of the graph. So you're going to hit window. You can also use the zoom feature. Sometimes I have a hard time with it, but it can work as well. But I'm going to go to my Y max. I'm going to pick a larger number. Let's just pick 100. And then I'm going to hit graph. And I'm going to see if the top of that graph shows up or not. Okay, and notice I can see more of it, but I can't see the whole thing. So you're going to have to sometimes play around with your window till you can see the whole graph. So I'm going to go back to Y max, and I'm going to hit 200, and because I'm going up, I'm going to change my scale to 10. And now I can see the whole graph. So it looks like I could have picked a number less than 200, but make sure you know what your window is so you can draw your graph the best you can. So here's my graph upside down. I want to know what this vertex is. This is the highest point of this graph. So we're going to hit second calc. And instead of minimum, I'm going to hit 4 for maximum. Hit enter. And it's the same thing as before. I need to be just to the left of my vertex. Hit enter. And then go just to the right somewhere. Hit enter. And now you've given your calculator a range of values and you're saying tell me the maximum point within that range. So hit enter. And it tells you that it is 1.9999, which is going to round to 2, and 114. Okay, so our vertex is 2, 114. Our axis of symmetry is always x equals the x value of our vertex, so x equals 2. For the x-intercepts, I'm going to plug in 0 for y, use the quadratic formula, so I'm going to go back to my calculator, hit program, enter, enter, and I'm going to plug in -16 for A, 64 for B, and 50 for C. And I'm going to round, I get -0.67 and 4.67. So come back over here, we're going to write these as 2 points. So I have -0.670 and 4.670. For the y-intercept, plug in 0 for t, and these two terms go away and you're left with 50. So x is 0, y is 50. Oops. Okay, so I'm going to do a rough sketch of this. So vertex is 2, 114. And there's 114. X-intercept's -0.67, so there's -1, and 1, 2, 3, 4, 5, 4.67, so somewhere right there, and y-intercept of 50, so that was 114, 50 would be about, whoops, right about here, sorry. Okay, that's supposed to say 50. So you just want to label your graph a little bit, and go up and around. There's my upside down U. Okay. Domain would be -infinity to infinity. Range, your y values, the largest y value you get is 114. So y is less than or equal to 114. Okay, that's supposed to be a 50 there. So just label yours. This is a little hard, a little bit more clearly. And then the last question says, what is the maximum height? I want you to highlight this. When you see max or min, remember what I'm asking you for is the y value of your vertex. That's always going to be your maximum or minimum. So in our case, our maximum height is the y value of our vertex, which is 114, and the unit is feet. So 114 feet. That's the maximum height that the rock reaches, and that reaches that at 2 seconds. Okay, last example says a company's weekly revenue is given by this quadratic, where x is the number of items produced during a week. What amount of items will produce the maximum revenue? So for maximum, again, I'm looking for the y value of my vertex. So let's go. You could do this algebraically, but we're going to try and graph this. So go back, hit y equals, clear, and plug in 200x minus 2x squared. And hit graph. Now you have to know that it's a -2x squared, so this is an upside down u, which is going to help you know how much of the graph you're seeing. And I'm only seeing one part of the graph. I'm not seeing the top or the other end of it. So let's go to Window. Actually, just to try something, let's go to Zoom. And you can try, let's see if I can find it. Scroll down. Zoom Fit. Whoops, went too far. Go up to Zoom Fit and see if you can get it to fit your graph in there. Okay, so mine is not showing, so I'm going to go back to window. First of all, I'm going to change these back. So -10. I can change my X max to 40 since I wasn't seeing all of it. We can go back and change this. Put your scale back to 1. Min, I'm going to keep, oops, I want a negative sign there. -10. Y max, let's try 300 and keep the scale at 10 and then hit graph. And you're really just trying numbers. Unless you want to find it algebraically, then you'd have an idea of what you might need. So I'm still not seeing the top of the graph. So let's go to Y max. I type in 500. Okay, so I'm going to change it to 500, and then I'm going to change my scale to 100 and hit graph. Okay, let's go back. Try 10,000. So we're going to try 10,000, and okay, I'm starting to see my graph. So I'm going to go back to my window, and I'm actually going to try 6,000, and I'm going to make my X max 500 and my scale 100, just because I'm trying to see if I can get this graph to show up. And there we have it. Okay, so you're going to have to play around with it sometimes till you get it so you can see the whole graph. So now that I have this graph, I want to find that vertex, that maximum value. So I'm going to hit second calc, and I'm looking for my maximum because it's the highest point, so number 4. And left bound. So first thing you have to find is your cursor. And these values kind of tell me where my cursor was, so I knew it was way down in the negative somewhere. So you just keep moving it, the arrow, till you can see it blinking. Left bound, I'm going to hit enter, and then go just to the right of your vertex, hit enter, and then enter. And I'm going to get 49.999, which rounds to 55,000. Okay, so let's go back to our problem. It says, what amount of items will produce the maximum revenue? So the maximum revenue is that Y value, which is $5,000. And that's gotten when you produce the 50 items. Okay, so max revenue of $5,000 when you produce 50 items. So that's what this company needs to do.